Good morning and welcome to today's live lesson. Your presenter today is Mr. OSEI. We'll be looking at atoms, elements, and compounds. You've got just under 5 minutes to complete the questions you can see on screen. If you have already done it, then you can just hang around whilst we give students the opportunity to finish this in 5 minutes. It will go a bit silent, but I'm still here. Thank you. You've got 5 minutes to finish 4 questions on the board. Thank you. Just a quick reminder, what I've done is I've highlighted some keywords, things which will help you to be able to understand how to do for question 1, question 2, and question 4. That will help you to understand exactly what you have to do to get the questions correct. So for example, question 1 has got 4 points, and I've highlighted 2 differences, 2 similarities, terms of electrons for question 1. Question 2, I've highlighted 2 differences, physical change, chemical change. We've got just under 2 minutes more to complete. Under 2 minutes more, thank you. Make sure you've got your periodic table with you. Whenever you have chemistry, make sure you have your periodic table by your side. Thank you. Time up. Let's look at the answers. So mark scheme. So 2 differences, 2 similarities in terms of electrons. So everything you mentioned should be about the electrons. So the first thing you write is chlorine has 17 electrons, sodium has 11 electrons. Again, you need your periodic table to be able to do this. Chlorine has 7 electrons in its outer shell. Sodium has 1 electron in its outer shell. Those are the differences. And then we come to similarities. So both chlorine and sodium have 2 electrons in their respective first shell or energy level. That gives you a point. The last but not the least is both chlorine and sodium have 8 electrons in their respective second shell or energy level. So the second shell or energy level of both atoms or elements have 8 electrons. Question 2, I put it in the form of a table just to make it easier and quicker for us to have a look at. So 2 differences, and we are talking about physical change and chemical change. So physical change, no new substance is formed. Chemical change, a new substance is formed. A physical change is reversible. Chemical change is irreversible or not reversible. The last question was, question 3, how many different elements are there in the periodic table? Take one. And I would choose the first one because it says about 100 elements. That is closer to the actual number of elements that we do have right now in terms of the periodic table. I know some of you will be asking, which is more than 100. Yes, I'm aware that it's more than 100, but that's the answer which is closest to the true value. And remember that examiners can put numbers like this, and you always have to choose the number which is closest to the true value. So if you look at your skills in maths, in terms of science, in terms of chemistry, so sometimes they will write 118, about 118 elements in the periodic table. And that is also right. That will be closer to the true value. So that is why the answer is 100 elements. You've got about 25 seconds more to complete your green pen. Again, I must mention here that if you are unable to complete your green pen improvement, this presentation and a PDF version will be available on VLA Live. If you go to live lessons, it will be available. So if you don't finish your green pen, I don't want you to panic. As usual, it will be available in the VLA. Okay, let's look at the last question. It says both group 1 elements and transition metals. Both group 1 elements and transition elements are metals. Describe 3 ways. So 3 ways in which transition elements are different from group 1. So it's just asking you to write down the differences between transition elements and group 1 elements. Okay, so, but the question is very specific. It says in which transition elements are different from group 1. So I'll urge you to write that for transition elements first. So again, I've given about 7 answers. So any of the 3 that you wrote down is correct. Any of the 3 is correct. So again, just to repeat it, transition elements were taught to you on Monday by Dr. Thompson. Dr. Thompson taught you this on Monday. So hopefully you should be able to remember some of these points. And then compared to the group 1, which also Dr. Thompson taught you. Okay, so group 1 and transition elements were taught by Dr. Thompson. I've got 2 more seconds to go. Thank you. So we want to look at atoms, elements, and compounds. We want to understand atoms, elements, and compounds. And what we want to achieve today, within the time that we've got, is number 1, to be able to define an atom and also define an element and show how atoms and elements can be represented. We'll want to define a compound and explain how compounds are formed. Finally, explain how chemical reactions can be represented. So at the end of the lesson, this is our aim, to make sure that you understand all this. So these are key things that AQ wants you to understand. Our key vocabulary for today is atom, element, compound, and chemical reaction. So if you can write that, the lesson, title of the lesson, and the keywords in your books, that would be fantastic. Go a few seconds more. So just make sure that you've written it. You don't need to write down the learning outcome unless you want to write it down. And you're welcome to do it. You're welcome to do it. So the first point is all substances are made of atoms, including yourself. A transmission electron microscope can be used to see nanoparticles and atoms. Atoms are so small that you need a special type of microscope, which we call as transition electron microscope, which allows you to see nanoparticles and atoms. What is an atom? An atom is the smallest part of an element that can exist. The first point is all substances are made of atoms. So you can see I've put some diagrams on the board. I've labeled a circle as elements, and in there are atoms. I've used color-coded circles just to let you know that elements are made up of the same type of atoms. So you don't need to color it. It's just an illustration to make it easier for you to understand. On the right-hand side, I've put some images. Again, the top one is to show you that you're also made up of atoms. So you've got Tropicana, which is a smooth orange drink. Again, it's also made up of atoms. Everything in there, including the plastic and the food in there. I've got a metal. Again, it's made up of atoms. So everything that you see around you is made up of atoms. How are atoms represented? Okay, so number one, atoms of elements are represented by a chemical symbol. Chemical symbols consist usually of 1, 2, or 3 letters. At your stage for AQA purposes, for the first 20 elements, you should know them, which is something you should know, and you realize that they are either made up of 1 or 2 letters. You always start with a capital letter, and any subsequent letter is in the lowercase. So capital letter for the first one, and if there's any other letter following, it's a small letter or a lowercase. So example is sodium, which is Na. The N is a capital letter, A is a small letter. You can never write capital N, capital A, or small n, small a, or small n, capital A. That is unacceptable. Other examples is O, which represents oxygen. K represents an atom of potassium. On the right-hand side, I've just put 2 things to show you the structure of chlorine and sodium. So I think the sodium is a GIF, which is showing an animation of elements in there. The most important things are this thing. Now I want us to have a look at chemical symbols. Why do some elements have chemical symbols different to their first letters? Okay, number one is to be able to distinguish them from other elements. That's the most important thing, to be able to distinguish them from other elements. So for example, sodium has the symbol Na. Okay, this is taken from its Latin name, the natrium. That's the Latin name. It distinguishes it from example nitrogen, which also has the first letter as N. So why are chemical symbols important? Number one, it's important because it's easier to represent elements using symbols. Number two, it makes it universal. Okay, it makes chemical symbols universal. The same symbols are used all over the world, whether you go to Russia, Germany, New Zealand, Iceland, United States of America, wherever you go, no matter which language is spoken, the chemical symbols of elements remains the same. Therefore, it makes it very, very useful for scientists to use. If you want to represent atoms using diagrams, how do you do it? Number one, you represent atoms often using circles. You can see I've put some colors in the circles. Again, let me point out here, it's just to make it easier for us to distinguish one atom from the other. Not that when you draw it, you should put colors in. Okay, so potassium is a circle, oxygen is a circle, chlorine is a circle. So you just draw circles to represent atoms using diagrams. Now we want to look at elements. Again, we said there are more than 100 different elements in the periodic table. So elements are always shown in the periodic table. So for example, you have hydrogen, you have nitrogen, you have fluorine, you have carbon, and you have potassium. These are all elements in the periodic table, which Dr. Thompson taught you when he came to do the periodic table. An element is a substance that contains only one type of atom. Now let me go back one step and then tell you about it, okay? 2 steps to be fair. So, I think it's ahead of us. So it's a substance containing only one type of atom. Number 2, it cannot be broken down into simpler substances by any chemical means. That is an element. If you look on the PowerPoint currently, you can see I've drawn 4 circles and I've put elements and atoms. So the circle on there represents our element, and the circles within it represents the atoms. So I'm looking at the one on my left-hand side, which is potassium. Potassium is an element. It is made up of only potassium atoms. So what I've done to make it very easy for us to recognize that it's made up of only potassium atoms is to use the same colored circles in here. Same colored circles. So I've put in blue color so to tell you that it's made up of the same type of atoms. The next one is carbon. Carbon is also an element. What I've done is to use black circles inside it. Why? Because atom is made up of only carbon atoms, and it's only one type of atom. Same goes for hydrogen, same goes for oxygen. Now we come to a compound. The question is, what is a compound? So it's a substance that is made from different elements that is chemically joined together or chemically bonded together. On the screen, you can see I've put a few images. If you look at water, water is H2O, and you can see that I represented water in a number of ways. So the first one here is showing an animation of water. I've used red to represent oxygen and the gray colors to represent hydrogen. Okay, so when we come to drawing it using the stick method, you can see I've used some sticks to join the oxygen to hydrogen to hydrogen, or the lines. Okay, so that shows the chemical bond between hydrogen and oxygen, between hydrogen and oxygen. This makes it a compound. Why? Because it's made from atoms of different elements that are chemically bonded together. How are compounds formed? Let's have a look at this animation. Very, very slow for you to be able to see what's happening. Okay, so let's go back again. There is a line joining the two red. The line breaks, or the bond breaks, and you can see the atoms of the elements has been released. Now they collide with other atoms of different elements, and a new substance is formed. So that is what the illustration is about. A new substance is formed. The new substance also have different properties compared to the original substances from which they were made. Let's take this for example. If I produce water from hydrogen and oxygen, hydrogen has its own peculiar properties, oxygen has its own peculiar properties. But as soon as hydrogen reacts with oxygen to form the water, water will then have properties which are different to that of hydrogen and different to that of oxygen, and that is why we say they have different properties. Number 2, the chemical reaction resulted in the formation of one or two new substances, in our case 2 new substances, and there were detectable energy changes. You do this when you get back to school. You do energy changes if you've not done it before. So what do compounds contain? Number 1, compounds contain 2 or more elements chemically combined. Not just chemically combined, but in a fixed proportion. Number 2, we can represent this compound using a formula. And the formula is a combination of the symbols of atoms from which they were made. We can separate compounds using chemical reactions. So if we ever want to separate compounds, we can use chemical reactions to separate them. Now, how do we represent chemical reactions? By word symbol equations. Now I'm going to throw up an animation. Look on the right hand side of this board and you see an animation coming up. Okay, let's see how chemical reactions are represented by. Okay, so look at it carefully. So first we had two molecules of hydrogen. Remember, hydrogen exists as a diatomic molecule which combines with one molecule of oxygen. Remember that oxygen is written as O2, and this is where students get it wrong. In exams, when you're asked to write down the formula of oxygen, is O2. The symbol of oxygen is O. Never forget this. Symbol of oxygen is O. Formula of oxygen is O2. So hydrogen combines with oxygen to form water, and that is exactly what's happening here. So you can see the red combined with two grays for hydrogen, one red is for oxygen. Let's put the word equation for another one that we are looking at. So the first example we are looking at is sodium and chlorine. So when sodium reacts with chlorine, you form sodium chloride. That's the word equation. Symbol equation is going to be Na plus Cl to give us NaCl. I think I put the wrong symbol equation, but that's fine. So word equation for sodium and chlorine is on there. So if you want to talk about formation of water, let's go back to the animation reaction. So that's the symbol equation at the top. H2 plus O2 to give us H2O. And that is our water. I want you to try this in your book. It says, write the word and symbol equations for the reaction between carbon and oxygen. I've given you the chemical symbol of carbon and I've given you that for oxygen. I want you to try writing it in your books right now. The word equation and the symbol equation for a reaction between carbon and oxygen. Okay. We've got about 1 minute and 20 seconds to try this. Those of you who are wondering about sodium and chlorine, I didn't put the symbol equation and the balance equation on the board. So the symbol equation and balance equation can see is that for forming water from hydrogen and oxygen. Okay, so the word equation is different from the symbol equation. We've got 2 seconds. Let's check our work and see whether we had it correct. So the word equation, any of the two you wrote is correct. Carbon plus oxygen to give you carbon dioxide, or carbon plus oxygen to give you carbon monoxide. Any of the two that you wrote is correct. Let's look at the symbol equation. Carbon plus oxygen gives you carbon dioxide, so C plus O2 gives you CO2, or C plus O2 gives you CO. I have balanced that for formation of carbon monoxide. I'm not teaching balance equations today, but I've just put it in for those of you who want to have a go at it or try it. Again, this will be available on VLE, so we can have a look at it later. Let's have a look at another example. I want to look at hydrochloric acid and sodium hydroxide. So tell me what you think this type of reaction is. Is it decomposition, precipitation, neutralization? saponification, hydrogenation. There are so many types of reactions. Okay, let's look at an animated acid-base reaction before we start. This is very quick. Look at it carefully. It moves very, very quick. I'll put the word equation in and the symbol equation in to help you to understand the animation better because it's very, very quick. So first, initially we had hydrochloric acid. Look at it carefully coming from the left, which combines with sodium hydroxide, which is our base, so the acid and base. And we ended up forming NaCl, which is the salt, and water. And that's what the animation is about. If we want to balance this, let's see whether there's anything to balance. There's nothing to balance. Why? Because the number of atoms on the left-hand side is equal to the number of atoms on the right-hand side. Not just counting all the atoms. Okay. So for example, if we pick up the number of atoms for hydrogen atoms on the left-hand side, there's one in sodium hydroxide and there's one in the acid. So there are 2 hydrogen atoms there. If you look on the right-hand side, water has 2 hydrogen atoms, and therefore we say that is balanced. We look at the next atom, okay, which is oxygen. There's 1 oxygen on the right-hand side and there's 1 oxygen on the left-hand side. Sodium, there's 1 on the right-hand side and there's 1 on the left-hand side. Chlorine, there's 1 there and there's 1 on the left-hand side too. Again, I'm not teaching balancing equation. That's why I'm going very fast through this. You can see next to the substances letters in brackets. So the first one is AQ, which stands for aqueous. Hydrochloric acid, AQ, which stands for aqueous. By the side of water, you can see a letter which says L in a bracket. It stands for liquid. These are the states in which our substances are in. I should have learned this in year 8, so I'm hoping that you do understand it, and or you do remember it. So S would have been for solid, L is for liquid, G for gas, AQ for aqueous. I want you to try this in your books, okay? You got a few seconds to do this. I think 1.5 minutes. Just a minute. Write word and symbol equations for the reaction between potassium and water. Again, I've put the chemical symbol for potassium, which is K, and water is H2O. If you want to try this in your books right now, please. Got a few seconds left. Okay, so I'll put the answers on the board. So word equation, potassium plus water will give you potassium hydroxide and hydrogen gas. Sorry, it's not plus water, it's plus hydrogen gas. So change the water there to hydrogen. Okay, it shouldn't be water, it should be potassium hydroxide plus hydrogen, not plus water. So change that to hydrogen. I'll put a simple equation. Potassium is a solid. Again, you can see what I was talking about. So the S is in a bracket which tells you the state of potassium. Water is a liquid. It should be L instead of the letter G. So water is a liquid, not a gas. Potassium hydroxide is aqueous and hydrogen is a gas. So there are a few errors to correct on the board. Okay, if you want to correct those ones right now. Okay, I'll go through again. Potassium plus water gives us potassium hydroxide plus hydrogen, not water, plus hydrogen, not water. Simple equation is potassium is solid, water is liquid, so replace the letter G with an L. Replace with an L, gives you potassium hydroxide, which is aqueous, plus hydrogen, which is gas. So those are the errors I want you to correct. Thank you. Go to the next slide. So how do we represent compounds? We can represent compounds using dots. and again the same circles. Now note carefully, with compounds, I've joined this together. So if for example this stands for water, oxygen is red and there are 2 hydrogen, but you can see they are all chemically joined together because it's a compound. Okay, so when you have a glass of water, you have so many water molecules in that glass of water. It's not just one. And that's why I've put 1, 2, 3, 4, 5. There are thousands and thousands of them, but I can't put everything here. Again, move to the right hand side and you see sodium chloride, which is salt, NaCl. Again, you can see I've put 2 circles which I've colored just to make it easier for us to distinguish between sodium and chlorine atoms which has come together. So that is a compound. Why? Because you can see those 2 dots are joined together. Again, as I mentioned, don't ever think there's only one sodium chloride in your salt. It's made up of thousands and thousands of them. And I've represented only 4 of them here, but in reality, there are thousands and thousands of them. Chemical formula. So chemical formula represents which elements are present in a compound, as well as the ratio of atoms in each unit of the compound. So if I write down a compound, for example, water, H2O, you can see the elements in here is H and O. H has a small 2 by its side, so that means for water, the ratio is 2 hydrogen to 1 oxygen. Let's look at the example I've put on the right hand side. Example here, I've put here. Sodium chloride. There's 1 sodium, there's 1 chlorine. So the ratio is 1 sodium is to 1 chlorine atom. So let's have a look at this. I want you to do this in your books right now and try them in your books. So I've given you the chemical formula of these compounds, and I want you to write down the ratios for me in the boxes provided. So I've got water, H2, and I've got carbon dioxide, CO2. I'll give you 20 seconds to write down the ratio for me. Thank you. Let's have a look at the answers. So for water, there's 2 hydrogen for every 1 oxygen atom. I've put the answer on the board. The second one is carbon dioxide. There's 1 carbon to every 2 oxygen atoms. So 1 carbon to every 2 oxygen atoms makes carbon dioxide. Quickly mark your work using a green pen or do your green pen improvements. I've got a quick retrieval practice. You have 10 seconds to answer each question. I want you to write down the letter corresponding to the correct answer. So I'm going to give you work and I'm going to give you possible answers. Just write the letter which you think is right. You've got 10 seconds for each one. So let's get ready. Get your books, get your pen. Off we go for the first question. What is the name of a substance containing only 1 type of atom, as shown in the diagram on the left-hand side? Thank you. Answer is an element, so you should have written down the letter A, an element. Let's look at the second question. You got 10 seconds for this. Thank you. And we got the answer as an atom. So it's an atom. It's an atom. Let's look at the third question. A, B, C, D. Got 10 seconds. Thank you. The answer is A. I've put in some notes because some students get confused between A and D. So A is a compound. Watch it carefully. Each of the substances in there is made up of 2 green dots and 1 red. Now go back to D and have a look. There are 2 different compounds in there, and therefore that cannot be a compound. Or there are 2 different substances in there, therefore that cannot be a compound. It should be the same form of substances in one compound. You can't give me a cup of water and say, I've given you water, and then all of a sudden I find salt in water. No. If you give me pure water, I'm expecting water, so it should be H2O only. You can't turn up and give me a cup of water and say, sir, this clean water, 100% water, distilled water, and I find salt in there. That is what is happening in D. So D is sort of, you got salt and water in there, okay? The A is just water on itself. Let's look at the next question. Which of the following represents an element? 10 seconds. Thank you. Amazing, amazing. It's C. Elements are made up of only one type of atom. So I'm expecting you to choose the one with only one color. Let's look at the next question. There are 2 of these which represents mixtures. I know you are going to do mixtures with Dr. Thompson next week. There are 2 of these. Can you choose them? You got 10 seconds, please. Well done. And the answer is B and D. B and D. Okay, so for example, D represents a mixture of water and salt. I was just talking about it because it's got 2 different compounds in there. B has got 2 different dots. And again, crucially, unlike A, they are not joined together, and therefore they are not chemically bonded. It's a mixture because you can separate it. Mixtures can be separated, and that is why we don't join them. Now you got true or false questions. I'll put one question at a time and you write down whether it's true or false in your book. Do not write down the questions. This will be made available on VLE. So if you want to make extra notes, you can do that. So the first question comes up and you got 10 seconds for each one of the questions. An element has 2 or more types of atoms. True or false? Thank you. The answer is false. An element is made up of only one type of atom, not 2 or more. Let's look at the second question. Atoms are the smallest part of an element that can exist. Yes, that is true. Let's look at the third question. A mixture can be easily separated. True or false? False is true. We can separate mixtures. Number 4. A compound can be easily separated. Is it true or false? A compound can be easily separated. Is it true or false? Okay, spot on. Yeah, it's false. A compound is a substance made up of 2 or more elements that has been chemically joined together. Is it true or false? You are spot on. It's true. Let's look at the next question. Water is an element. Water is an element. Is it true or false? Well done. It's false. The last question. Oxygen is an element. Oxygen is an element. Is it true or false? Fantastic. Of course, it's an element. Okay.